We are breaking out this step, designing your database, into a separate slide presentation because, unfortunately, it's not as easy as it looks. The problem is that you're most likely coming from a spreadsheet. So where we're going here is we're going to show you a typical spreadsheet and the way to solve the problem, which is removing duplicate data. Database people refer to this as normalization, but normalization is nothing more than taking the redundancy out of your data. So let's look at a typical spreadsheet. What you'll see here is some customer and order information. Now your spreadsheet may look entirely different, but it is very likely, because of the nature of spreadsheets and their limitations, to contain similar types of issues. So here we have customer A and customer B, but you will notice that customer A is repeated 3 times and customer B is repeated twice. This is because the customer has ordered multiple things from you. So customer A has order number 100, order number 145, customer B has a couple of orders of their own. The reason why customer A has order number 100 repeated twice is because he ordered 2 separate items on that order: the running shoes and some socks. So what you're seeing here is multiple levels of redundancy in the data. In order to build an effective database, we will not be able to simply import this spreadsheet. We will have to figure out how to restructure our order information. Let's jump back to the slides. So we need to rethink our data. Some things appear more than once, as we saw in that table. If it repeats more than once, there's a very good chance that that piece of data deserves its own table. So for example, in the spreadsheet, we see that customer names repeat frequently. This means that the customer information probably needs its own table. We see that order numbers sometimes repeat because people have multiple line items on their order. Therefore, orders probably needs to be in its own table. We see things like order status repeat multiple times. This means that we can expand order status out to its own table. And of course, rather than copying and pasting names for things that people ordered, it would be much nicer if we had a list of products that we could just select from. Let's go back to the slide. So we will come back to this again and again, but each table must have a primary key. This is absolutely central to how databases function. A primary key is nothing more than a column in a table that uniquely identifies the rows. You can't have any duplicates. The most common example would be something like a customer number column in a customers table, or a product number column in a products table. You could also have, generally speaking, 2 different types of primary keys: automatic and manual. Automatic are ones like customer number, where you have customer 1, customer 2, customer 3. They're generally numeric, sequential, and automatically generated. Manual primary keys are things, for example, like a status code, where you might have status equals shipped, or packing, or returned, etc. 99% of the time, the automatic counter is what you want. The exception are these very simple lists. Foreign keys. What are these things? It's central to how a database works. So the formal definition of a foreign key is a column in one table that refers to a primary key column in another table. And most people shake their head when you say that. It's simply a link between tables. So we needed to pick an example to show you how things work. We decided to go with an orders example, not because it directly reflects your data, but because everyone has experience with orders. Everyone knows that you have customers and orders, and you order things, products. So you already have a lot of experience with it, so that's where we're going to start. Your data is different unless you're doing an order system, but conceptually you'll run into all of the same issues. So here we go. For our order spreadsheet, we had everything jammed into one table. Maybe we had it spread out across multiple different spreadsheets, and maybe it's more complicated than this, but inevitably it needs to be restructured. So how do we do this? This is the first point that usually trips people up when they are designing their own database, especially the first time. You need to create the tables in the order that makes logical sense, so that if table A is referring to table B, it can't do so unless table B exists. So in our example, we're going to break this down into a table of customers, a table of order statuses, a table of orders, a table of products, and a table of order items. Now, you'll see more of how these are created and relate to each other, but it is important to emphasize again and again that the customers table needs to be created before the orders table, because the orders table is going to refer to the customer. Again, the order status needs to be created before the orders table, because the orders are going to have an order status. They can't if they can't refer to that table. Again, products need to be created before order items, which are the line items on an order, because the order items are going to refer to particular products. And a key point here is that this order of creating the tables is also going to apply when you import the data for the exact same reasons. You can't import data that refers to other data if that data does not yet exist. Before we jump back into the application and actually create these tables and show you how it works, remember that your spreadsheet probably contains a lot of duplicate data, and it's not going to map directly to a worthwhile database without a rethink. The order of creating the tables is important. Table A can't refer to table B if table B doesn't exist yet. And the same thing applies to importing data. If you're trying to import some data that refers to other data, but that data doesn't yet exist in the database, you are going to get referential integrity errors, and it's not going to allow you to do it. It won't hurt anything, but it will not allow you to do it. Okay, let's jump back to actually creating these tables in Parasql.